Hi, everyone. So as Craig said, my name's Colin, and I'm going to be talking to you about Cursive, which is an IDE you might like to use to edit your Clojure code. So I've been working on Cursive on and off for a couple of years now. The first public beta came out about a little bit over a year now, in October of last year. And since then, the response has really been great. As Craig mentioned, it's now officially the second most used editing environment for Clojure. We beat Vim by 1 vote. Yes. But it's really fantastic. I'm really pleased everyone likes Cursive as much as I do. I'm very pleased. It's currently developed as a plugin to IntelliJ. So you need to download IntelliJ and install it into it. It does work with the free community edition of IntelliJ, so you can just download that and plug it in. It will eventually be a standalone IDE as well. So JetBrains, who make IntelliJ a couple of years ago, split IntelliJ into what is basically an IDE building platform, and also the IDE functionality that's built on top of that, all the Java support, which is now just a plugin to that platform. It will be commercial. I am going to be charging money for this, just so everyone's aware of that up front. It'll cost more or less about the same as the smaller JetBrains IDEs, so PyCharm for Python or RubyMine for Ruby, if you're familiar with those. So it's based on a very old fork of Clojure, which was the original Clojure plugin for IntelliJ, and that was actually developed by a couple of JetBrains employees in their spare time. But it was never really a focus for JetBrains as a company, so I don't think any of their employees actually ever were paid to work on it for any reasonable length of time. And it was sort of languishing a little bit, so they got a little bit of updates, but really nothing was happening to it. So I started using it because I'd been programming in Java for years, and I was used to IntelliJ. I didn't want to have to learn Emacs or whatever to program in Clojure, but I very quickly got frustrated with it. So I forked it, and I started to update it. But the problem was it's all written in Java, and I didn't want to be writing Java. I wanted to be writing Clojure. So I gradually migrated the interesting bits from Java to Clojure, and now pretty much all the interesting code is written in Clojure. So I'd like to do a quick little demo just of some of the basic functionality so you have some kind of idea what it looks like. So all your basic functionality works, so things like you can get your completion here, it shows you the name, it shows you the arg list, the namespace things are coming from, and this works equally for your local symbols here, or something for Clojure.core like defen, for example. And again, you get all your information down in the completion. You can get your Java doc there. It actually doesn't come up very well in the IntelliJ presentation mode, but believe me, that is actually the Java doc for defen. You can get the information on the parameters while you're editing a particular function invocation. You can get the source code of something immediately in a pop-up there. You can see all the symbols that are in your current file. This is just a small file I have as a demo, so there's not a lot there, but you can see them all pretty easily. So the thing that might be surprising about this to most of you is that I don't have a REPL running. So all of this functionality is provided by Cursive by statically analyzing the source code. So odds are, statistically, most of you are using one of these to edit your Clojure code. So these all have one principal thing in common, which is that they're basically text editors. They really provide no syntactic analysis or semantic analysis of of the actual program. They don't really understand Clojure at any sort of fundamental level. The fact that so what they basically do is they will connect to a REPL, and all the information, the editor functionality, will actually come from the REPL, from introspecting the REPL. So you're looking up the documentation, it will go out to the REPL, look up the documentation from the metadata of the var that you're talking about, and show that in the editor. So this has the advantage that it's very accurate, right? So you start up, you have a copy of your system running, and the editor knows exactly what's there. And people really like this feeling that you're kind of interacting with your application, that your application is like a sort of living thing. But they're very accurate only for the information that actually exists at runtime, which in Clojure is basically vars. Vars and I guess Java classes as well. So they require your application to be running where you get no editor support, but so I think pretty much everyone's workflow is you start up your editor, you start up a REPL, and then you're good to go. But I think the most important limitation of systems like this is they don't allow indexing. So indexing is really the basis of a lot of really interesting functionality that I think is pretty fundamental to being able to develop, particularly renaming, for example. So So if you rename a symbol, you need to be able to rename not just the symbol, but everywhere in your project where that symbol appears. And you really need some sort of indexing to be able to do that. So why would you want to use something like IntelliJ to edit your source code? So IntelliJ provides true syntactic analysis of your code. So if you're programming, and here I'm mostly talking about using Java for IntelliJ, that's the main implementation. It's by far the most mature language implementation they have. So when you open a project in IntelliJ, it will actually parse the entire project, it will index it. So it actually builds a syntax tree for your entire project, indexes all the useful elements, and that allows a lot of really, really interesting functionality. The refactoring is a totally integral part of the workflow of anyone working with IntelliJ. And when I'm developing Java in IntelliJ, I'm continuously refactoring things. I'm extracting variables, I'm extracting methods, I'm moving things around, I'm pushing up parameters. It's an absolutely fundamental part of the way you work. And the navigation is also totally flawless. Again, it understands the whole project, it has it all indexed, so it can provide all the navigation that you might want while you're actually editing your code. This is particularly important in Java or any sort of object-oriented language where you have really deep hierarchies. So you might want to see things like where a particular interface is implemented, what all your superclasses or your subclasses are. And all that is totally flawless. It just works perfectly every time. It has a really interesting system of live static analysis in the editor. So it has a system of inspections. So while you're actually working on your code, the IDE is continuously running static analysis of your code, and it marks the errors or the warnings right in the editor. And it will often provide quick fixes for them there as well. And it provides what are called intentions, which are really tiny code manipulations, just so things like, I want to swap the sense of this if statement, it'll just swap the if and else branches, and it'll swap the sense of the predicate. And it has hundreds and hundreds of these for Java. So the sum total of all of this means that when I'm working on Java with IntelliJ, that I actually feel like I'm working directly on the syntax of my program. I feel like I'm actually manipulating the structure of my program directly. And this is because the commands that are provided by the editor very directly represent exactly what I want to do. So the conceptual operations that I want to perform in my program are provided to me in the editor as direct commands. So I don't have to be messing around with text. There's no sort of cutting and pasting this around or paredit or whatever. I just tell the editor exactly conceptually what I want to happen to my program, and it does it right pretty much every time. So this is always, and so none of this comes for free, obviously. There's a performance cost to a lot of this functionality. There's a memory cost, so you probably need a more powerful development machine than if you were using Emacs or whatever. And obviously it's very complex functionality as well. There might be bugs in it or whatever. But in a perfect world, when all that works, it's incredible how much that just removes all the distractions from your programming. And it allows you to really focus on what you're actually trying to do. Because let's face it, when you're sitting down to program, what you really want to be doing is thinking about the problem you're trying to solve and manipulating your program to achieve that result. And this is always my ultimate aim with Cursive. I have a really, really long way to go, partly because of the characteristics of Clojure as a language, but also because it's taken dozens of people way smarter than me a decade to do it for Java. So there's a long way to go, but it's gradually getting there bit by bit. And that's always my ultimate aim, even if I never actually get there. So this is something I see online quite a lot. IntelliJ is great and all, but I type much faster in Emacs or Vim or Sublime Text or whatever it happens to be. This, I think, is pretty misguided. I think that when we're working on our programs, our tooling should provide support to directly manipulate our programs. We shouldn't have to be mucking around with text. I think lack of typing is a feature. When I'm actually not typing very much in IntelliJ, it's not like I don't want to type because I'm lazy. I know how to type. I can type quite fast. But if I'm not typing, that means I'm able to express to my editor exactly what I want to do in terms of higher level operations. And that's what I think we need to achieve. I think text is the wrong level of abstraction for editing our programs. And I can see a bunch of you jumping up and down now saying, I have paredit, I don't need all this. Paredit is great. Cursive provides pretty much a full implementation of paredit, and you definitely need it for any sort of parenthesis-based language. But it's not sufficient. It's not really syntax aware. It doesn't really understand your language at all. Parredit works equivalently for any Lisp-based thing, so you can use it for eLisp, Scheme, Common Lisp, Clojure, whatever. But it works equivalently for all of them because it doesn't really understand any of them, except at a very basic level. So I think of it as the equivalent in English of making sure that all your sentences are in full stops. You have to do it, obviously. It's very important that you do it, but it's far from being the most important or the most interesting thing about the grammar. So for those of you using Emacs, there's a project called CLJ Refactor. I haven't actually used it myself because I don't use Emacs very much, but from looking at the documentation, this I think is much more what we need to be aiming for. So it provides, again, these kind of higher-level operations which are working on specifically on the language. So one thing to notice about it is that it's CLJ Refactor. It's specific to Clojure. And really, you can't have sophisticated tooling without it being aware of the language that you're editing to a level that Parredit is not. And this is another thing that I see quite a lot. Never send an IDE to do a programming language's job. And this, I think, probably comes out of a lot of people's distaste for Java. And again, I think this is also quite misguided. I absolutely think we should be trying to have more sophisticated languages, more expressive languages, better languages. And it's really exciting to see in the last sort of 5 years that there are very interesting languages coming into the mainstream. But I think editor support is largely orthogonal to language features. They really don't have that much to do with each other. And I think more sophisticated languages could potentially benefit even more from this sort of support. If you imagine languages with very sophisticated type systems, Haskell, OCaml, languages like this, I think they could have really, really amazing support in something like IntelliJ. So the main reason this sort of support doesn't exist in languages is that it's very, very hard to develop. I mean, it's a huge amount of work. IntelliJ is millions of lines of code. It's easily equivalent to the complexity of writing a compiler for the language, and it's probably even more than that because it's a compiler that also has to deal with the fact that your AST might be broken at any time, or in fact, absolutely will be broken all the time while the user is editing their program. Plus, you need a whole bunch of extra functionality on top of that, so they're very complex pieces of software these days. But the fact that it doesn't exist doesn't mean it's not desirable, and I think a lot of people conflate that. They tend to think, my favorite language doesn't have this sort of support, and that must be because it doesn't need it. And I don't think that's true. I personally believe that most languages could benefit from this sort of support, but it is very, very difficult to develop. I don't think we should confuse those 2 points. So I wanted to talk a little bit about the infrastructure that IntelliJ provides, and then I'll talk a little bit about how Cursive takes advantage of that. So one really fundamental concept in IntelliJ that most other editors don't have is the concept of references. So given some program element that's a reference to something else, what does it refer to? Where is the thing that it refers to? What sort of thing is it? What can I do with it? And this is required for pretty much all sorts of IDE magic. Any slightly advanced functionality that the IDE does is based on this. So an IntelliJ reference is a cross-language. So when you have some Clojure source with any sort of interop, you have symbols there representing classes, methods, and these all are references to their corresponding Java elements in the syntax tree. Cursive also provides some support in the other direction. So from your Java source, if you're using rt.var or api.var, something like that, to call into Clojure from Java, it provides some support for that now. And of course, classically in Java IDEs, there have always been a lot of references from XML into Java code. So the key operation with a reference is resolve. So given something, I call resolve on it, and it gives me back the thing that it refers to. And implementing this, basically simulating the language semantics in the editor, is a lot of work. So I have here it accounts for around 60% of my time. I think that's probably not true anymore. The infrastructure in Cursive is getting pretty good now. It's mostly, I wouldn't say it's done, but it's getting to the stage where most of the work is done. But certainly in the first year of serious Cursive development, I would say at least 60% of my time went on this. So here's an example just to illustrate. There's 2 little functions there. You don't really have to care about what they do. It's not so important. So here, the blue box at the top of item check, that's the definition or the declaration of it. So you're declaring, or defining rather, a function there called item check. And all the item check elements below with the orange boxes around them, those are references to them. So if I have any one of those later item check elements, I can call resolve on it, and I'll get back the blue one at the top. And this works equivalently for local and for global symbols, and also for symbols across different languages, all of that. So the inverse operation to resolve is called find usages. So this is basically, resolve goes from a reference to something to the definition of it. And find usages is, given the definition of this thing, what are all the things that reference it? So the classical operation you need that for is rename, right? If you want to rename something, you need to rename the thing itself, and then you also need to rename everywhere there are references to it in your program. So this is based on an inverted index that IntelliJ maintains of all identifiers in your program. And so when you call this operation, it'll actually go through and basically get all the words in your program that look like it might be a reference to the thing you're asking about, and it will check to see whether they really refer to it or not. So IntelliJ has really great multi-core support. This is all done in parallel, so it's actually a pretty fast operation. So this is used, IntelliJ actually has a user-facing find usages operation. I think this is an absolutely fundamental tool for development. I don't know how anyone lives without it, to be honest. But it's also used under the hood in most refactorings and a lot of inspections. Again, this is an incredibly common operation. And again, anything interesting in the IDE is going to have this in there somewhere. It has a really great indexing framework. So it actually has a couple of different levels of indexes. I'll only talk about the one that Cursive actually uses. It uses a thing called file-based indexes, which is essentially, you can think of it as a map. So it has a kind of map-reduce architecture, so I register with IntelliJ. I have these indexes, and these are the file types that they're interested in. IntelliJ will call me back saying, I have these new files of this type, and then I return back the index data. So I basically return back essentially a map. The keys and values are totally arbitrary data, and by providing a serializer to IntelliJ, I can use whatever types I like. So I've provided a serializer to IntelliJ that allows me to serialize arbitrary Clojure data. So this is actually really nice. I can now index everything, and when I look up something in an index, I get back a Clojure map. It works really, really nicely with Clojure. And the keys are just used to look up, obviously. So implicit in one of these index entries is the file where the data was actually encountered. So I can also I can query based on any number of scopes. So I can say, get me something from these indexes, but only from production code, or only for test code, or only for my project code, but not libraries, or only my library code, or only code from this library. It's very, very slick. And the really, really clever bit is that indexes are automatically updated. So as you're editing your program, obviously the index data can all get out of date, and IntelliJ is very, very good at updating those. So it'll do that when I actually ask for some information from the index. IntelliJ will realize that some files that might be touched by that index have been updated, and at that point, it will re-index. So for me as a user of the API, the index data is always up to date. And that's the piece of code, if you're implementing an editor, that you really don't want to have to write yourself. It provides some support for refactoring, but the refactoring support is you don't get an awful lot out of the box. So the problem is that refactorings, even the same refactoring for different languages, are actually pretty different. So an extract method in something like Python is very different to Java. So there's really not a lot it can do to provide a lot of this out of the box. So what it does is it has sort of like a workflow framework. So it has essentially the workflow that you would normally go through to provide a typical extract method operation, for example. And you can plug into that at different points, and you can customize for the language that you're supporting different aspects of this operation at different points. The one thing that you do get out of the box for simple cases is rename, because again, the symbol resolution works, so IntelliJ can just say, okay, you're renaming this thing, you have a bunch of symbols that are references to it, I'll just assume you want to rename those to the new name as well. But everything that's more complex needs a bit of work. So again, the inspections, so this provides real-time linting and static analysis in the editor. So if you're familiar with tools like Kibit or Eastwood, they're generally run offline. IntelliJ provides the infrastructure to provide that sort of tooling live in the editor. And again, it's all marked live. As soon as you change something that would produce an error, it's immediately marked, and there's often a fix provided as well. So for something like Kibit, you can imagine normally Kibit will run over your source code and will say, hey, at this file, this line, you have this piece of code, you might want to replace it with this other piece of code. So in IntelliJ, it can actually provide a quick fix. You just go to the warning and say, make it look like this, and it'll work. It has a really fantastic infrastructure. There are multiple different parsers with different priorities at different stages of the analysis. Most of the analysis is asynchronous. They have separate high priority parsers for the visible area. It's all run in parallel on multi-cores. And when you're editing and updating your program, it's very, very good at identifying the minimal affected scope that it needs to re-inspect in order to maintain those annotations. accurate. And again, the intentions are these kind of micro refactorings I spoke about earlier. So inspections will warn you about potential problems in your code, things you might want to look at, things you might want to change. Intentions will allow you to modify your already working code to produce more, hopefully, working code. These are often used as fixes for inspections, but they're often standalone as well, and they're context sensitive. So you don't have to remember a million different key combinations for these. IntelliJ will prompt you if you're in a point where you could apply one of these things, and you can just automatically accept it. So things you might want to do in Clojure, for example, if you're refactoring a piece of code and you end up with one let block inside another, you could merge those together. If you have a really long let block, you might want to split it for some reason. If you have a long let block and you realize suddenly that a variable in the middle you want to use if let or when let, you might be able to just split that out. Converting an function literal to an FN form, something like that. So again, none of these are particularly difficult or onerous if you're good with paredit, but the sorts of, all the operations that you need to do to perform these transformations are not anything to do with the conceptual operation that you're trying to perform. And I think that's really important. I think it's really important that your editor allows you to directly express the operations that you're trying to do. So I'm going to make a shameless appeal to authority here. For those who don't know Olin Shivers, he's been around forever in the scheme world. I object to doing things that computers can do, and so do I. I would like my editor to do them for me. Ironically, he probably uses Emacs. So I wanted to talk a little bit about the implementation of Cursive. And in particular, the most important problem with doing something like Cursive or implementing any sort of IDE for a Lisp is macros. So Cursive works on the unexpanded source. And obviously, macros can do absolutely anything when you expand them. And in fact, in Clojure, most core functionality of the language is actually macros. So a lot of things you think of as being primitives in the language, things like defin and let, they're not actually core language forms, they're actually macros. And Cursive has no way to automatically see inside a macro to see what it's doing. So the most important thing that generally we want to see is what are the vars that this macro defines, what are the local bindings that this macro defines, and what are their scopes. And often, symbols that are defined by macros may not even exist in source code at all. And this is something that traditionally IntelliJ has a bit of a problem with, because in a traditional language, everything is defined somewhere in your program. But in Clojure, if you think about it, if you have a record you've defined with def record, it will create a constructor function for you. So this is this thing with the arrow pointing to the record name. So it's just a function you can use to construct a record. That has no representation whatsoever in your program. So you have to be able to handle that, which is tricky. So the first thing anyone says when I tell them about this, they say, why don't you just expand the macros? It's easy, right? So the problem is, macros are completely arbitrary code. So they might never terminate, and you can never tell ahead of time whether it's actually going to terminate or not. You can't look at a macro and work out whether it's going to finish. That's the halting problem, which is a fundamental problem you cannot solve. It could use a huge amount of resource. It might use a lot of memory. It might take forever. Or it might chew up a bunch of your disk space. You don't really know. It could format your hard drive. It could send rockets to the moon. And I thought this was I thought I was getting kind of crazy with some of the examples here. And I was talking to someone at the scheme workshop yesterday, and they told me about a macro in scheme that will shell out and execute a C compiler during macro expansion. Please don't do that. But people do these things. So this list is actually direct from the Cursive issue tracker. Francesco Bellomi put it on there, and he makes a project called CrossCLJ. It's a really fantastic project. So he basically cross-references and indexes a bunch of libraries in the Clojure ecosystem, and he provides a website where they link them all together. It's really neat. So he actually expands all the macros and works out the references traditionally doing that way. And he said that those first two, that macro expansion sometimes never terminates or it uses a huge amount of resource, are things that he sees relatively frequently. So this does happen. And even assuming you could do that, the problem is you have your macro, you expand it, you don't really understand anything about the macro expansion, and you end up with this huge ball of expanded code at the end of it. And to automatically relate elements from that expanded code back to the unexpanded source is very difficult, because your user, when they're editing the unexpanded source, and that's conceptually what they're thinking about. They're not thinking about the macro expanded code. David Nolan told me the other day, no one wants to know what their macro expansions look like, so you're fine. So it's very difficult. So the trivial cases are relatively trivial, and I guess a lot of people, when they're saying, why don't you just expand the macros, they're thinking about something like a standard def template with just a syntax quote in it. And that's relatively simple. You can generally see what's going on there. But again, in the case like the record constructor function, that's a very difficult case to handle, because in your macro expanded code, you suddenly have this definition of a symbol. And if someone tries to rename that, what should you do? You can't automatically determine that the name of that symbol is based on the name of the record. So you really need some sort of understanding there to be able to handle this. So what I did in Cursive was I actually implemented everything around an extension API. And everything internally in Cursive is based around this as well. So whenever I'm adding support in Cursive for built-in forms, this all uses this API as well. So it's keyed off the head symbol for list. So you can see an example there. Register locals, Clojure core def, and def and symbol. So what that's doing is that's saying, when you see a list where the head symbol in the list is a macro and it resolves to Clojure core def and minus, then use the def and symbols function to return to Cursive what the local variables are and what their scopes are. One thing to notice is that the keyword there is fully qualified. So since Cursive can actually resolve accurately, you can actually discriminate based on the fully qualified symbol. And this is important these days because if you have a form starting with just defn, you don't know. It might be Clojure core defn, it might be schema defn, it might be core type defn. So there are a lot of different things here, and you have to be able to distinguish them because you have to treat them differently. So these extensions are just functions. They can be reused, they can be composed. And so this API will be opened up, and all the existing implementations will be open source as well, so that people will be able to add support to Cursive for the libraries they use, the libraries they develop. Or if you have internal macro systems at your work, you'll be able to add support for those as well. And my hope is that by using simple functions, it'll actually be relatively trivial to add support for new forms that look similar to existing forms in the language. So these are the sorts of things that you can currently teach Cursive about through extensions. So local bindings, we talked about previously, what they are, where they are, what their scopes are. Global vars, so you return to Cursive something that looks very much like var metadata. Extracting information from forms for indexing, so aliases, refers, imports. Threading forms, is this form a threading form? And if so, where's its implicit parameter? Where does its implicit parameter come from? And that'll be important when I'm implementing type inference. Class definition, does this form define a class? And formatting, so you can actually now customize the formatting for specific forms as well. And soon they'll be adding support for completion, so you'll actually be able to have context-sensitive completion. So if you're in an NS form, for example, and you're requiring some namespace and you have an excludes form there, when you're in the excludes vector in your completions, you only want to see symbols from the namespace that you're requiring. You don't want to see anything else. And there are certain cases where you need to have interactions with refactorings for particular forms and so on. So I wanted to do a quick demo for you to show some of this functionality and show some of the functionality that maybe you haven't seen in existing systems. So one great thing about indexing source is that all this works equivalently for local variables, for global variables. It's all just references. So one thing to notice is that when I have the caret over a symbol here, Cursive knows what it resolves to. So it will highlight the definition of the thing that your caret is over plus all the references. And again, this works for locals, for globals, things from Clojure core, anything. And one really nice aspect about the fact that I'm indexing source code is that all this functionality works transparently for Clojure script because the source is basically the same. I needed to add some support for the interop forms and whatnot, but it all pretty much works as you're going to see it here in Clojure script. So I can also rename things here. So I can rename that. And that will rename the definition and all the usages. So if you're renaming something like a record, it will also rename the record constructor functions. So it'll do a lot of these auxiliary rename tasks. And again, this works equivalently for locals, for globals. I can change this however I want. And find usages, which is what I talked about previously. This is a really fundamental operation, I think. So when I look at this, it tells me this is the only usage of make set. But if I look at something like println here, for example, this will show me everywhere in my project that println is used. And I get a little bit of a preview there. So here I only have a single file, but if you have a really big project across multiple files, you maybe don't understand the whole project, a lot of it was written by other people, this is just an amazingly useful tool. And if I want more detail, I can actually get it in a little preview window down here, which again is kind of small. But as I go over the usages here, I get a preview on the right, so I can get a bit of context and I can see what that usage looks like. So Cursive recently learned how to do all this for keywords as well. So when I put the caret on a keyword, it will highlight all usages of the keyword. And one nice thing to notice there is that it also highlights all variables that are used in keys destructuring forms. And this also works for rename and find usages. So if I do a find usages on that keyword, it shows me everywhere in my project that that keyword is used, including the variables that are destructured from it using a keys binding. And I can also rename it. So if I rename that to first name, for example, that renames the keyword, again, ever in the project, plus the variables where it's used. So I don't know about you guys. I'm often hunting through my project trying to find ever I use a keyword because I either want to rename the keyword or I want to change the semantics of how it works. This is just amazingly useful. It's totally accurate. It works every time. So again, we have the whole project index, so we can do some quite cool stuff. So here in my completion, I'm saying stir, and it's saying Clojure.string trim. But instead of the namespace, it's saying Clojure.string as stir at the end there. And so what that's saying is, you don't have this required in your namespace at the moment, but I've seen that somewhere else in your project, you've required Clojure.string with the stir alias. So if I autocomplete that there, it automatically adds the require. This is really, really useful. Again, like I'm working on my program, I'm down in the guts of it, and I know I want to use set difference or something, so I type it in, and it's automatically added to my namespace. I don't have to be jumping up to my namespace, editing a bunch of text, adding that in, going back to where I was, trying to remember what I was doing, getting back into my flow. That's just really annoying. So that's a really useful piece of functionality. And something else that got added recently, if I delete that, Cursive will also mark in the require that that alias is no longer used. I'm actually quite embarrassed to admit how many aliases I managed to, or how many requires I managed to go back and delete from the Cursive source code. So another thing is that if Cursive suddenly sees a variable that it doesn't recognize, but it can find it in another namespace, then it will also offer to import it in the same way. So that's now required it there. And this is really, really useful when you're cutting and pasting code from one namespace to another. So you can get a bunch of code from one namespace, you paste it into a different namespace, and it will prompt you immediately to add all the requires you need to make that code valid. That's really, really, a really useful piece of functionality. So now that you have this ability to add requires willy-nilly and not even really think about which namespace you're in or the namespaces that your things are coming from, it's quite easy to add circular dependencies, and Clojure really doesn't like these. So I have a little namespace here in another file that I set up just to illustrate this. So if I autocomplete that, it'll actually warn me. So again, I have all the namespaces indexed. I know what the dependencies between them are. I can trivially check. You're adding this new dependency. You're going to introduce a cycle. And I can show what it is. It will actually go ahead and add the require, but it'll warn you, and you'll have to fix it. All this functionality works equivalently for Java as well. In the interest of time, I won't actually show that. But you can add the short name for a class. It will prompt you which class you might want to import, and so on and so forth. All the documentation and navigation works. If you get the documentation for a Java symbol as if you were getting it for a Clojure symbol, it'll show you the Java doc. It all works in exactly the same way. Unused imports will also be marked in your NS form. Again, I cleaned up, when I added this the other day, I actually cleaned up 500 imports from the Cursive code base. So the ultimate goal here is that you should never have to look at your NS form. I hate that thing. I don't want to have to look at it, and I don't want you to have to look at it either. Ideally, for those of you who have programmed in Java using IntelliJ, you never see your imports anymore. It's always folded up the top. You never have to look at it. The IDE maintains it, and it's always right. Because of the way Clojure works, that may not be 100% achievable in Clojure. But I think we can get pretty close to it, and I'm aiming to get as close as I possibly can. This is something else that was added recently. So I can invoke the neighbors function here, but Cursive will warn me. So these are the inspections I was talking about previously. Cursive will warn me here that the arity that I'm calling with is not correct. So neighbors takes, it can take two arities. It can either take 2 or 3 things. So I add 1, that's still no good. 2, and it's happy with that. 3, and it's happy with that. 4, and it's no longer happy. And this is immediately marked in your editor. And I think this is really important. So as Clojure developers, when we start using a REPL, one of the things we're really trying to achieve with the REPL is we're trying to close that feedback loop as much as possible. We're trying to get our feedback as quickly as possible. We don't want long compile cycles. We don't want to have to be waiting for a minute after we've made a change to see what happens. So things like the arity check, even if you're running a REPL, you can load that code into the REPL, and Clojure won't warn you right away. It'll only warn you when you try and execute it. And this inspection finds real bugs in people's code. And in fact, I released it, and like 12 hours later, a user wrote to the mailing list saying, oh my God, there's just found a bug in our code. They had tests for it, but they hadn't found it because Midge was helpfully stubbing out the function. So they had a function call with the wrong arity, a real bug in their code, and this found it. And again, something else to notice here is I can update this. I can add a new parameter here to our function. So suddenly, the call we made down the bottom is valid. That's not marked anymore, and calls at other sites are marked as invalid. So one other thing to notice here is that param is marked as unused. So local variables will be marked as unused if you don't use them. If I comment out this piece of code, for example, all of a sudden size and UIX are marked as unused. This is really, really useful. When you're refactoring, you're moving bits of code around. It's very easy to move a symbol, rename it, and forget to update where it's actually declared. So that will, this will warn you right away. You can introduce, there's some simple refactorings now, so I can actually introduce this. I'll call this. And so what I'm actually doing here is I select the expression that I want to extract into a let binding. In this case, I want to extract this. And then I identify the point in my program where I'm going to introduce it. So I'd like to introduce it around this try block. And then I'm going to call this loader right there. Thank you. It gets better. Watch this. So I decide I want to do this. So there's actually 2 occurrences here. So Cursive will actually go through and say, hey, from where you're extracting this, there's 2 occurrences of this. You might want to do that. You might want to extract both of them. So I'll say, yeah, sure, I'd like to do that. And now the scope that it offers me has to be valid for all the occurrences. So it's a much more limited scope that it actually offers me to be able to do that. So I add it here, and that's my thread. And the other thing to notice there is that normally when it adds a binding to a new let form, it'll add it at the end. In this case, it knows that some later value in the let binding actually used that value, so it has to put it before it in the let form. So it will actually insert it into the correct point in the let form. And it knows that because it can resolve the symbols, right? You have to be able to resolve symbols to do this. So here is something else. I want to do this all the time, right? Whenever this happens often when I'm using sum, so I will have a list of things, and I often want to nest my function literals, but you can't do that in Clojure because I guess it makes the parameters ambiguous. So again, it's marked in immediately as an error in the editor, and you get a quick fix. So I can convert the inner one to an fn, and then I have to decide what I want to call it. That's a y. Or I can convert the outer one to an fn. So I hope that kind of shows you some of the functionality that Cursive has that maybe you might not have seen in other tools, what the infrastructure that Cursive provides will actually permit. So if you take one thing away from this talk, what I'd really like it to be is that our tools should allow us to work directly on our programs. We shouldn't be working on text. Text is just the wrong level. I think text is a perfectly good serialization medium for our programs, but you shouldn't have to be working with it while you're manipulating them. Our programs should enable us to to use conceptual operations to update our program. And that means that our tools need to be language aware. They need to provide manipulations that are specific to the language. And the fact that it's hard to implement doesn't mean it's not desirable. You should absolutely be demanding that your tool users provide this sort of functionality. It's really, really useful. It just makes your life so much better. And I guess probably a lot of you will go off to design languages for fun and or profit. Please, keep this in mind when you're designing your language. Make it easy to parse. Keep the semantics simple. Don't have lots of really crazy corner cases. And ideally, you should really develop the tooling along with the language, I think. Because I think the sort of support is, I think it's the future of tooling for languages. So I have a bunch of future plans I don't have time to talk about. I am running an unsession at 9 p.m. tonight, so if you want to come, questions, comments, effusive praise, abuse, it's all welcome. That'd be great. Thank you very much.